Let's now summarize about typecasting, especially compilation versus runtime. The example I use is actually this particular variable declaration with a static type and dynamic type. Let's now try to visualize it, and then you can still go over the points in the slides. Let's now take a look. Okay. So this is the type hierarchy for the inheritance for the smartphone example that we have been talking about. And I'm going to use this particular example to summarize about what you should know about a typecast. Okay, let's now do that. First thing first, my phone over here has the static type Android, dynamic type Samsung. Samsung can fulfill the expectation of the static type Android. We know that very well. So this line compiles. Let's now try to use the color carefully. So here you can see Android over here is the static type of my phone, right? Let's now write it down. So this is the static type of my phone versus Samsung over here is the dynamic type. Yeah, I can actually do this. That's fine. So that will be dynamic type. So this is the dynamic type of my phone. All right, let's now talk about the cast. Okay. First of all, let's distinguish between compilable versus non-compilable at the compilation time. Okay, compilable can either be upward casting or downward casting, right? With respect to the static type. It's really important to really say with respect to. So this would be with respect to the static type of the variable. So we can either do upward casting or downward casting. Let's talk about upward casting. So we can go along the ancestor path. So that's the only class that we can upward cast to. Okay, and we can also do downward casting. So we're gonna follow the link for the reverse direction for the extents, basically, right? For all the descending classes over here, and you can see here. So these are all the classes, including the Android itself. So these are all the classes where we can downward cast into to really widen the expectation, right? So here, and also let's just be complete. This class over here, this class over here, and two more. This class over here, and also this class over here. So all the green, okay, over here. And let me just make a little bit more notes for you, okay? So this direction over here is really upward casting. Upward casting, which will actually get, in which case we'll get narrower expectation. Narrower expectations. Versus when we do this way, we are doing downward casting. Downward casting, in that case, we get a wider range of expectation. Okay, so that's also very important for you to remember, right? When we talk about compilable cast, either upward or downward. And any other classes will be considered as non-compilable cast, non-compilable, meaning that it's neither ancestor nor descendants that we are cast into. In which case, I'm going to use our orange over here. Okay, orange here. So I'm just going to say here, this one here, and also this one here, and this one over here. And let's make a explicit written notes over here. So these classes over here, these classes neither ancestor nor descendants of the static type of the variable, my phone, right? Static type of my phone. So that's why they will not even compile. All right, so now we're gonna say for those classes which will compile by doing either upward casting or downward casting, we want to split it into two categories. Now we talk about runtime. So far we only talk about compile time. So these cast will not even compile, right? So that means you cannot even execute your code. What about either we got no exceptions or we got class cast exception? So now how do we tell? In this case, we have to bring the dynamic type into play, which is over here. The idea would be if each all the classes over here, if you cast into it, they will just compile because they are either ancestor or descendants. But some of them will actually run into class cast exception because those cast type cannot be fulfilled for expectation by the dynamic type for the variable. Correct? So now, what classes cannot be fulfilled for its expectation by Samsung? Put it in that way, it should be its child or its children's children, and etc. As long as it is not the ancestor for the dynamic type. In that case, like these two, that means you're going to run into class cast exception. Let's annotate it, and I'll write it down for the principle. And this will actually link very well into the next topic after the exercise when we talk about instance of operator. Okay, so let's talk about class cast exception over here. So let me use a red. Okay, let's say class cast exception over here. Okay, so class cast exception, so only these two. Okay, only these two. So we run into class cast exception. Okay, how about this? Let's say it compiles. Oh, actually, not only these two. I beg your pardon. These two are actually just it's more like a. It's not exactly, or it's not like just descendants because descendant also includes Samsung. So they are like a proper descendants. Proper descendants simply means it's children and also the children's children, right? These and also this part over here. Let me just try to also highlight this part here, and also these classes over here, right? So these two sets over here. So they are going to trigger class cast exception. Let's see why. Okay, so this one here and also this one over here, all of them is going to run into class cast exception. They compiles, but class cast exception. Let me emphasize that. Compiles, but class cast exception. Because they are not the ancestor classes of the dynamic type of my phone. Again, why is it so important for them to be the ancestor class in order not to have the class cast exception? They are not the ancestor classes of the dynamic type. Is really important because let's think about what if they are the ancestor classes. If they are the ancestor classes, for example, Samsung or Android or smartphone. So these are the ancestor classes that you can cast into, and also you wouldn't run into class cast exception because the dynamic type Samsung can definitely fulfill the expectation for itself and also its parents, its grandparents, and all its ancestors. That's why. On the other hand, can Samsung fulfill the expectation for its strict like a proper descendant, like a child? In this case, no. Galaxy S21 or Galaxy S21 Plus, for example, these two classes might contain some extra methods or attributes that are not available in Samsung, right? They might, but we just didn't really have them in the diagram. Okay, may contain extra expectations, like a code. Okay, and also this one will be also easy. You can see zoomage over here. You can see zoomage over here cannot be fulfilled by Samsung. Okay, let me just draw the connection over here. Cannot be fulfilled. Can't be fulfilled. All right, so that's about the summary of all the different categories over here, right? Hopefully, you don't need me a recap. You can just rewatch this part to see how I do this the categorization for these four. Okay, compilation and also runtime. For runtime, it can either be exception free or you might run into class cast exception. Oh, finally, the blue one, right? Let's now do a final box. This class over here, and also this class over here, and also this class over here. So these classes will be the cases where we compile and also runtime exception free. Okay, so this one here, and also this one over here. Compile and exception free. Class cast exception specifically. Exception free. Because they are ancestor of the dynamic type of my phone's dynamic type. It's really important to actually see this, right? Compile and also exception free because they are ancestor of the dynamic type, not the static type, dynamic type, right? Okay, so now review this part very carefully because this really summarizes everything that we have said this week about the cast.